Alan, Rohit, and others. So, welcome to this live session on 4.0. Yeah, it's cross 7, so we can actually start the session formally. So let's start with your queries, your questions, your comments. Who wants to go first? Anyone?
Sure. Then maybe we can start off with demonstration of the a priori algorithm. Rohit, can you start off with that? And maybe later on we'll ask if there are any doubts. We'll come back. If no one has any doubts, that is.
Sure.
Yes.
Oh, sir, are you sharing your screen or shall I?
No,
Yeah,
you
can
please,
go ahead.
you please share. You please go ahead. So let me give a 1-minute summary of a priori. Let me recall what a priori was. A priori essentially is some way of calculating conditional probability through data, right? But we are not interested in calculating the probability. We are essentially interested in calculating the or arriving at some rules, right? So if this happens, what is the probability of something else happening? If we did the a priori algorithm in the context of supplier characteristics, if this is done in terms of retail transactions, so essentially we are asking that question: if this product is bought, what is the probability that some other product was also bought along with this, right? So knowing that this product is already bought, what is the probability that the other product was also bought? So that's what essentially we are calculating. Essentially that's what we are doing. So Rohit will tell us the mechanics and the mathematics of this.
Okay, so this is the sample data that was presented in the tutorial. It contains 20.
Yeah, go ahead, Rohit. Sorry.
Okay, it contains 20 samples, and you have 3 properties about the suppliers: the quality, reputation, the price premium, and the management. And all these are ranked from 1 to 3, 1 being the highest rank, and 3 being the lowest rank. So that's the data set that we have. And is my collab page visible? Is the code page visible?
Yes.
Yes.
So I'm just loading the data here, and I'm just loading it as a uh, data frame, a pandas data frame, and the pandas data frame looks something like this. So here you can see the same data has been collected as a data frame in Python, and if you see, there is also an additional list that is created, which is nothing but the index of the row and the description about the supplier. And here, since we are not, so a rank 3 in quality reputation does not equate to a rank 3 in price premium or rank 3 in management. We need to classify, we need to be cautious of the fact that this 3 corresponds to only quality reputation. So what we are doing is that we are just appending the column name to every rank in that specific column. So here you can see if it's 3, 3, 1, the data set would look like quality reputation 3, price premium 3, and management 1. So this is the data set that will be used for the a priori algorithm. So how does the a priori, so a set of definitions in the, so first step is to find the number of unique things that are available in the sample space. So the number of unique things is nothing but, here if you see, I'm just creating a unique list, which is so every qual so every property has three values possible, and there are three properties: quality, reputation, price premium, and management. So it's 3 cross 3. So there are 9 such possibilities for any sequence to occur, and we are having 20 data points. So the so it will be a 20 cross 9 matrix. And what will this matrix contain? This matrix will essentially contain 0 or 1. So I'm just creating the 0 matrix as of now. So Z is the matrix that we are creating. If you just print it now, it will be 0. But if you just for the so you know the order in which you're going to, so every row will have 9 columns, 9 values, and you put a 1 in that specific column if you find that specific property in the description of your supplier. For example, for example, if you find price premium 1 in any of the suppliers, you'll put 1 at the starting of the first index of the row itself. So that's what is happening here. Wherever you find the data, you just replace the value by 1. So this is the Z matrix. So here you can see that. So so here you can see that the Z matrix is created. And sir, do you want to give a background on the item set support definitions before going into the formula?
No, if you have that slide, that slide has the equation for support and lift and all that, right?
Okay. One second.
Yeah.
Yes. I think it's a little before.
So confidence, lift, and support. So yeah.
Okay,
You can go ahead, Rohit.
I don't have the entire slide. That's why.
Okay. So as I said, right, essentially they are mimics of our conditional probability, right? Mimics of our conditional probability, and then that is support. Let me also pull up my definitions. Just give me 1 minute. Right. Yes.
So to put it in simple terms, you need to find an item set. An item set is nothing but a subset of your sample space.
Exactly.
And support is nothing but the probability of finding that subset in the entire data set. It's just the probability of finding that sequence in the entire data set. And if you while defining confidence, confidence is nothing but the conditional probability.
Yeah.
So you divide the item set into two parts called an A and B.
And B.
And now what you're trying to find is that what is the probability of finding the subset B given the subset A of the item set. So that's the confidence. So here you can see how. So here you can see that how support is calculated. It is just calculated if you have so an item, for example, let's consider an item set or so here you can see that these are the different subsets that we are item sets that we are considering. And first you have to calculate the support for the item set, because you're not splitting the item set into A and B. You'll split the items into A and B only when you're supposed to calculate the confidence. So there are two steps to the a priori algorithm. First calculating the support, and then giving a cutoff for the support, and then taking and then among the item sets that have a minimum support, you try to calculate the confidence And I think you can also put a cutoff on the confidence.
Yes.
But yeah, so depending upon so there will be two layers. First, you'll put a cutoff on the support, mainly because that support should have a reasonable probability of, first of all, occurring in the data set. Only then you can speak about conditional probability of subsetting into two subsets of A and B. So that's the idea. So here you can see how the support logic is present. So if you find so an item set is nothing but a subset of the entire sample space, right? So for a given row, for example, if you take this subset, so this subset contains management 2, and wherever in the data set, wherever you in the data set you have management 2, you will be increasing the counter, and you will be dividing it by the total number of and you'll be dividing it by the total number of data points that you have, that is n, which is 20 here. So you will just see how many times an element of the item set is present in the in the rows of the data set, and that's how you will calculate the support. And here, if you see these are the samples, and if you see, this is the set of all item sets and support calculation. So if you look into this list, you will get an idea of what I'm speaking. So once again, I think I printed everything. So here you can see, if the item set, if the item set is just management 1 comma management 2, the support is 0. Basically it means that you don't find such a combination in the entire data set with reasonable probability. That's what it is happening. And why are we starting with a minimum size of 2? Because we need to split the item set into two subsets, two non-zero subsets A and B, and so we are starting with a minimum size of 2, and we are increasing the size. So that's how even the code is written. So so if you look into the code more closely, there is a library called as combinations, which allows us to create different combinations of a given subset, a given list. So here you can see that you, first of all, you create a list of size k. So how do we do it? To calculate all the supports, all the possible item sets, you first fix the item set size. So let's say 2. So we need to get set of all possible item sets that have size 2, and in that size 2 you find all the combinations. So basically, now if you see the number of individual characteristics is 9, and so if you are finding the number of items that have size 2, it's nothing but 9c2, and the number of item sets with size 3 is 9c3, and so on. So that's why you can see that the number is very large. It's around 520, just 502 just for a 9 combination problem. And now what I'm doing is that I'm giving a minimum support condition of 0.2, meaning that I'll only consider item sets that have a minimum support of 0.2 for the given data set. And so what I'm doing is that I'm in that support pair, I'm just taking the item set that has a minimum support of 0.2, and then I am creating a new list called as high support item set list. And if you see the size here, it has only 8 item sets, which has a minimum support of greater than 0.2. So these are the item sets that have a minimum support greater than 0.2. Any doubts still here? Hello, any doubts? Is it clear till support? Hello, am I audible?
Yes, but you are audible. I believe none of the participants are audible.
Yes, sir.
Okay, okay, okay. So till now you have only calculated the item sets and their supports. Okay, now is the next part, splitting the item sets into two parts, A and B, and then seeing whether there is a conditional probability, a non-zero conditional probability per se. So how do you do that? You take the item set pair from the set of all these 8 things, these 8 item sets, and you randomly split it into 2 parts. So here you can see that I'm calculating the item set size, and so as you know, when you're splitting, you need to split it into 2 non-zero sized subsets, or the both of them should not be null basically. So what I'm doing is that for every, so if this, let's say the size of the item set is 3, that means I will range from 0 1, so it will start from 1 2, that's all. So you will create a combination of size 1, and then what you'll do, and that set of elements will be taken as set A, and the complementary of that set from the item set that we have considered will be considered as set B. So that's how we have done here. So here you can see that, so we have taken set A and the complementary. How do I take the complementary? So I have the item set here, and then I'm taking difference with respect to the set A, and so we'll get the complementary with respect to the item set that we are considering, and then we are calculating confidence and lift. And all this thing is just for the sake of logging the results, and then you create the association rule. Let's try to run this and understand. So here I'm not giving any additional condition over the confidence. I'm just calculating the confidence and lift with respect to the the confidence and the lift with respect to the high support item sets. So here you can see 24 will be totally coming. So if you try to print the rules to understand, here you can see that before you saw that there was an item set with management 1 and price premium 3 with the support of 0.2, right? So that is split into management 1 and price premium 3. So how do I read it? Given management 1, the probability of getting price premium 3 is 0.667. That's how you should read it. So confidence is nothing but the conditional probability, right? So given the set A has occurred, what is the probability that set B would occur in the data set? That is how association rules are defined. So this is called as confidence. And what is lift? Lift is nothing but the gain, the ratio gain with respect to the confidence and the probability of just observing set B. The probability of just observing set B. So it is how much times the probability has improved just by giving an additional information that set A has already occurred. That's what is called as lift. So lift can be calculated by using the definition of confidence and support itself already. And here you can see the set of all possibilities. So I have taken a simpler example of 2 cases. Let's see an example of 3. This last one, management. So yeah, so here you can see that if price premium 3 and quality reputation is 3, then the probability that the management will also be in rank 3. So remember that rank 3 corresponds to low sub average performance. It's not even average. So 1 is above average, 2 is average, 3 is below average. And you can see that the confidence is 0.36 and the lift is 1.3639. Yeah, and the support is 0.2. So this is how you calculate association, or this is how you find the association rules for a given data set. Any doubts till now, or do you need any explanation specifically better in any
Please reconfirm the lift, sir, once again. What exactly that means?
So yeah, let us go to the definition of lift itself.
Sure.
So first of all, you understand what is support, right? Support is not support of a set in the data set is nothing but what is the probability that this sequence will occur. Basically, that's it, right? Now, what is confidence? Confidence is nothing but the probability that this sequence B or this pattern B will occur, given pattern A has already occurred. Okay. Now, let's talk in simple terms. Let's say let's say you're doing something and you're guessing probability, and I give you additional information, and you're now improving your probability or improving your estimate. Now, by taking the ratio of your previous estimate to the current estimate, you can quantify that how much useful that condition given was useful to you, right? Basically, how much useful was A useful to you? Basically, let's have simple numbers. Let's say the probability of just observing set B normally in the data set is 0.2. Okay, and now the probability of observing set B given set A in the data set is 0.4. Okay, now I ask you a question. What, how, just because I gave you an additional information of set A has already occurred, how much times is the probability, like how much times is the probability, what is the lift in the probability of set B occurring now? You understand the question now? Hello, am I audible? Hello?
Yes,
Rohit.
we can use the Bayes rules in this case, and we get the probability of B given A already occurred.
So no, Bayes rule. No, I'm not talking about A given B. So you have already calculated B given A, right? That is nothing but confidence, correct?
Yes, sir.
Yes. And you know what is probability of B, correct?
Correct, sir.
Yeah. Now taking the ratio of these two, wouldn't it quantify what is the additional value that condition is bringing into to your decision making? Condition that set A has already occurred. I'm trying to give you an intuitive logic of what is lift.
So in case of Bayes rules, what is given? Given means already occurred.
Yes.
So you are saying the same thing. If that is confidence.
Okay, lift is essentially lift has three broad interpretations. If the lift value turns out to be 1, that means A and B are not pretty much correlated. There is no correlation between A and B, right? Now you may find the confidence for that to be high, but that may be a fluke confidence because there is a third guy present. That is clarified by lift, which is why lift is important to calculate. Lift of 1, even if we get support value to be very high, even if we get confidence value to be high, right? Even if we get confidence value to be high, if lift is 1, that is essentially telling us that A and B need not be associated. It may be a very spurious association because you have to look for some C which is affecting A and B both. So lift separates that part. If lift is less than 1, essentially means that if somebody has bought A, they will avoid B. And if lift is more than 1, it means the opposite. It means if A was bought, it is quite likely that B will be bought. So those are the three broad interpretations of lift, and that's why we calculate lift in addition to confidence. Does it help?
Sir, in other terms, if I said that this is equivalent to correlation.
No, it is not. No, the problem is correlation. Analogy will not be perfect because lift can be more than 1. Confidence, correlation cannot be more than 1.
Okay.
Right, broadly, but that's how you interpret lift.
But we can say it's at whether it is positively correlated or negatively correlated. If it is positively correlated, then we can say that it is greater than 1. If it is negatively correlated, that means if you buy A, then we will not buy B.
Roughly correct. Roughly correct. Yes.
Okay, sir.
Good heuristic.
Okay, sir.
Any other questions? Or any doubts in the code logic? Sir, should we also ask them about any doubts with respect to the assignment from a priori? Or?
Yeah. Obviously, this is an open forum, right? They can ask us questions on anything.
So if you have any doubts in the assignment also, yeah.
Rohit, yeah, in case the assignment is not yet closed, then don't disclose the answer, or else it's fine.
I think it was already closed.
Yeah, then it's okay. Then they can ask any questions. You can also discuss the answer if you want to. Let me just check in the meantime. Let me just do
Yeah,
a
please.
back and
Very,
check.
very, very good point, Malala.
Yeah.
I would not have noticed it. Good.
I think, yeah.
Assignment 2, right? Assignment 2 was a priori.
Assignment 1 was a priori. 1 and 2. 1 was a priori and 2 was Bellman and stochastic inventory.
Correct. So 1 and 2 both are closed.
Yes, yes.
Yeah. So everything is fine.
Hello, sir.
Yeah.
Sir, I have question related to second assignment, second part.
Second,
Here we have data for multiple regression.
multiple regression.
Yeah. Sir, I do the calculation using the Excel sheet and I got the answer about point
Oh, 1 second. Multiple regression meaning where? Like,
second part. No, not there. Assignment to second part.
oh, you're talking about assignment 2. Okay.
Yeah.
Let me just bring that up. Give me a moment. Yeah.
Oh.
And
Can I share the assignment, Rohit?
yeah. If
Better. Yeah, better.
Okay.
see, yeah.
1 minute. Okay, I hope the screen is visible. This first part. This is assignment 2 for industry 4.0. So which question are you talking about?
I think 11, second part.
11. Okay.
Yeah.
So what is the specific doubt in the question?
Which inventory size will have a maximum
Sir,
value?
it is industry 4.
No, it is industry 4.0.
Yeah.
Business assignment.
So, business analytics.
I think one
I suspected,
miscommunication is.
that's what I suspected, that the course is
Yes, sir.
incorrect.
Actually, sir, we received a mail regarding this is the business analytics interaction.
Yeah.
No, it is not. No, it is not.
No,
It
it
is
is
industry
not.
4.2.
Industry 4.0.
Okay, so then
Oh my God, all of you guys. The most funny thing is, sir, we have been discussing a priori algorithm with them, and they have all been listening without telling anything.
no,
Sir,
actually,
I-
sir, Sam tried
You're
to search
finding
the
it
code.
interesting, sir. That's why
Yeah.
we were quiet.
Okay. So is there anybody from 4.0 here, or everybody from BA only?
I am from BA.
From BA.
Yeah, anybody from industry 4.0 just raise their hand, and otherwise, because yeah, then we are in incorrect meeting room.
Okay, sorry, sir. We got a message for that BA only.
We got a message for BA.
Yes, we received a mail that today we have a live session from 7.
I had posted it here in business analytics, and this was for BA only. We had specifically told them.
Yes, sir. It's
I-
written that on the mail. It is for the BA, and so I was surprised that.
For 4.0 assignment. Oh,
The mail was about BA.
Yes, sir, and came to the BA student only. So
Okay, sure.
okay, there's been a complete mix up from the back end, I believe.
No issues. Anyway, they got to learn a new algorithm. Good that we positively contributed.
Right, sir.
Okay, but no, I don't think we are ready to answer BA because I am not prepared for BA.
Yes, sir. But
Specifically, if you have conceptual questions from BA, I can still answer. If you have questions from assignments in BA, I am not prepared.
yeah, for the
Sir,
assignment, I believe.
Sir, it is not a specific assignment. It is general conceptual
Sure,
question.
please go ahead. Please go ahead.
Sir, in 11th question assignment 2, I do the calculation using the Excel and got the difference of approx 0.004 or 2. In
Expected.
Excel and in Excel and in Colab, the difference
Yeah.
is.
Expected. Which is why in assignment we clearly say what to use.
Yes, sir.
Okay.
Sir, the confusion is in Excel I simply select the data,
Ah.
X variable, number of X variables and Y variables,
Yeah, yeah.
and the Excel gives the result. But in Colab, we have to split the data into test and one other thing,
Train.
test and train data. Why there is a difference in Excel and Colab? I'm not getting the point.
Because that would be because of your random seed. So in Excel, you are manually selecting one portion of it, right? It need not be that the model selects the same portion when you do it in Colab. It starts from a random point and selects 80%. That is why
In
the
Excel.
is important. In Python, Colab,
Yeah,
you choose 80%. You don't know which 80 points are taken out of 100, right?
yeah,
It
right.
it could have taken those 20 points that you did not choose in your test, your train in Colab. That would be determined by your random state. So that is why you fix a random state. We ask you to fix it at 0, then generate a train data set so that whatever results you get would match with the results that we have computed for.
Okay.
Right?
And then how? Yeah. Then how Excel is calculating?
Excel, you are manually selecting now.
Oh, I select the full range of X variables.
So you have not selected this thing. What is that? You have not split anything. You have taken the entire data as train.
Yeah.
Correct.
Yeah,
So
correct.
we have taken only 80% of that in your this thing. In your what is that? In your Colab.
In Colab, we have taken only 80%.
Yeah. But in Excel, I have selected 100%.
100%. So in the range is different, and hence the values of your coefficients are different.
Okay. The difference is only a minor. The answer is here.
Correct. Because only 20% is varying.
Yeah.
That is why I believe if you have taken in your any MLF or MLT courses, I believe how they will train their model is they will do this a large number of times. They will take random 80%, 80%, 80%, do the model, build several models over large number of data sets, and then use the best model from that.
Okay.
I believe that is what they would have done in MLF or MLT, some version of
You're
this.
right, sir. It's called cross-validation.
Cross-validation, correct? Yeah, so you have seen that. So that is what they do in their tools. Here, we are not worried about that large number of times. We just want to know whether you are able to interpret and understand the business concept and give an answer. So that is why the variation would be very small, but there will be a variation.
Yeah. Okay, sir.
So in fact, do one thing. Instead of taking 80-20 split, in Python also give the entire data set. In Excel also give the same data set. Get the answer. It should match.
Okay, I will check it.
For linear regression, it will match. Let me put that clause also. For linear regression, it will match. Let's say you are solving this for the logistic regression, it will not. Because the optimization softwares on the back end of Excel and the back end of Python are different. Okay.
Okay, sir.
I hope
Sir,
you are able to understand.
I have one doubt in grade assignment 2, question number 9 and 10.
Okay, number 9 and 10.
Yes.
Okay.
So this is the beta 0 and beta 1. The calculations are we have seen in the lecture. We have to take the anti-log to get the value. So that's what I did. But the answer here it is without taking that anti-log.
You take anti-log. Why do you take anti-log? Beta 0 and beta 1 are direct.
No, sir, because we have to convert that for ln. No?
Okay, with the transform data set, yeah, okay. With the
Yeah.
transform data set, what is the value? What are the parameter values for beta 0 and beta 1? Let me just check what transformation
Yes,
he
sir.
has done.
Please check,
But
sir.
even then, even if the transformation is there, I don't think you take an anti-log because he's asking you for the beta naught. You're building the beta naught for the transformed variables.
Yes, because once you take the log, sir, because that
You are taking the log on the. I don't know whether you are taking the log. If I remember right, are you taking y is equal to or are you taking y is equal to ln x? Which answer? It is ln y is equal to ln x.
Wait, sir, I'm telling you.
So the answer given here is ln y tilde ln x versus ln x.
Yeah, ln y, ln x I have taken.
So yeah, y itself becomes ln y. So
that
x becomes ln x. So I don't believe you will take a ln for your betas. You will have to take the direct betas, no? Sir, am I wrong somewhere? Or is this right?
No, sir. I'm just telling, sir, whatever I have learned through the video lectures. I may be wrong, sir. That is why I want to just
No,
check.
understood.
So let me think this through. Let me think this through. I will have to look at this question more carefully.
Okay.
Okay, sir.
And the response also, and your response. Now I have understand what you are saying. Let me take a look at the question also, but I can't do it in real time.
Okay, sir. Okay. And sir, one more small clarification,
Mhm.
Malwan sir.
Mhm.
In the graded assignment 1,
Mhm.
grade assignment 1, that question, that the expected value, that question number 5.
Mhm.
Sir, what I did actually, I did it in Python, means Google Colab.
Mhm.
The difference actually I distributed among all and taken and do the rest of the calculation.
Mhm.
So my answer is coming 0.458 something. So I written in 2 digits 0.45 and I become wrong. Had it been
No, just check if you had done it. This is the value you would have got, because I have done
No,
it and
I can
have
do
given
one
you the
thing, sir.
response here. Yeah.
I have done this in the Colab. So I take that entire code and send it to you in the Discord. You please just check, because I got the answer at 0.458 something,
One second.
but
let
I
me
have
just-
written it's 0.45.
No, let me just check, because I've already done the calculations. If I can, question number 5.
Had it I been rounded off that 8, I become right 0.46, but I didn't do that.
No, because
actually.
I am not able to give the mark primarily because it's very, very close with others. Yeah. So I had told you a fix, and if you do the fix, the p-value that you get would be 0.47. Then you have not done the fix correctly.
Okay, sir, I will just maybe I have done this in Colab. Yeah,
okay,
I will
just check your computations once more, because
Huh.
this is the p-value that you should get, because this is the p-value. I've got same thing using Colab.
Okay,
After
sir,
doing
I
the
will
same
check
thing
once
using
more,
Colab.
and I also send that to you. If I unable to find where I am going wrong, then you just help me.
Yeah, sure, not a problem. But this is the computation. It should be 0.4722. But the correct approach would give you 0.58.
Yeah, that part I
the
understood, sir.
The fixed value should give you 0.4722. So just check your computations. Okay.
Okay. And sir, I have one more small request, sir. Because since today there is a mismatch, although it is a industry 4.0 we got, but always others are live interaction session is always uploaded into the schedule, so that we must know at least 2-3 days ahead ki there is a live interaction. But here we didn't find anything in our calendar for BA.
Okay, really, last time when we had a BA session, we had informed the team 2 days ago. The link had gone only in the last minute. Same way, this time I had told this for industry 4.0, but the link has gone as BA. So I don't know what is happening. Maybe they are getting confused since it's the same team. I believe that is what is happening. I will just have a word with them. It will reflect in your calendar. That is what I'm trying to say.
Yeah, it's not reflected.
That is something that mismatch has happened.
Okay, so one more, because why? If it is in the calendar, if I miss this interaction, I can see that is in later time. But now
you are asking for recorded sessions.
Not recorded. If I miss, then I can go to the calendar and check with the YouTube. But here there is no link at all.
Okay, I do not know what is happening. Like I said, there is something that is going wrong in this term. We will try to rectify it as soon as possible. The same thing is happening with our uploads also. So we had something in the last term. When it's getting replicated here, there are errors that are happening. The questions are getting mixed up, so on and so forth. So we are just rectifying that. We'll find the source and we'll get it rectified. Okay.
Okay.
Malwan sir, good evening. Can I ask from week 7?
Week 7, sure. Logistics.
Yeah.
Yeah, go ahead.
So with confusion matrix, if it is given just the confusion matrix, how we will calculate the beta 0 and beta 1?
When you are given the confusion matrix, you will not be able to calculate beta 0, beta 1.
Because the question number 8 and 9 is provided this data.
Which one? In the practice assignment?
Yes, sir.
Okay. Practice assignment, question number.
Yeah,
Eight.
this one. This just giving the confusion matrix.
No. That is what I'm trying to say. Okay. This someone has already raised in our portal. Thanks for bringing it up.
Yes, sir. I mentioned.
You
it.
mentioned these questions are not from this week. These questions, beta 0, beta 1, and transform data set, questions 8, 9, and 10 are actually from the previous week. They have come here. This is what I was referring to. For some reason, these 3 questions, which were in the previous week's content, have been brought here. It was not there in the previous term. So,
And also, sir, here, if you go above, sir, just
Yeah.
go to that assignment, sir.
Hmm.
There is one more point in the practice assignment, sir.
yeah, this is the practice.
No, but-
Industry 4.0. Okay, since it's
Just go above, sir.
Okay.
There is 2 questions, 4 and 5.
What is the precision of the model? What is the recall of the model?
Yes, now you check the answer, sir. You go down and check, go down. Check answer and go and check, sir, that 2 answers, sir.
4 and 5. Cannot say.
Yes.
Correct, because I've not given you precision of what recall for what.
But,
Y is
sir,
equal to 0, Y is
generally-
equal to 1.
Generally, what is the problem?
Hmm.
In this type of platform, we don't
Sir,
say
if you read
instead
the
of-
question, it is asked to enter the value in 2 point decimal values.
Exactly, sir. And
Given the
one more
following
thing,
is
sir.
the thing.
Not
We generally do not
question
write
number 4.
4 and
Okay.
5.
So
So we generally do not write
4 and 5.
anything because anybody can write anything that will
Correct,
not
correct.
match. It
This-
should
there
comes
is-
under selection. Multiple
these two questions, if you're asking for the format, I have deliberately given it as a this thing. Because we are not grading your this thing. Unlike other courses where for solving practice assignments you get marks, this course it's not like that. These questions are deliberately given as such. You are right, I could have given multiple options, then it would have become very clear. Cannot say would have automatically triggered. Why I have not given it as a multiple select option is this is the only place where I can make you enter anything, but you should match the response that is got. You might be marked wrong, given a 0 for saying something else, but you should know that you cannot calculate. Right? So that is why these are not given as a MSQ and given as a blank and with a rounded decimal number. So you can basically say, okay, 0 will not make sense. You can basically say cannot predict. Maybe I can put or enter in words. So that it becomes clear. But the purpose of why this is not given as a multiple choice or a multiple select or any other clue is for learners to understand that you cannot calculate this for the given data. Okay, so that is why it's given like this. I didn't want to give any clues away. That is the only reason.
And in the question number 6, by default threshold is 0.5. We are getting some values for the accuracy. And if we increase that from 0.5 to 0.6, 7, 8, and up to 9, as per answer, it is decrease, then increase. Up to 0.9, I am not getting any increased value.
Just check it once more. Let me just try to.
Because in 0.6, also 0.5, 0.6, it gives the same result.
1 second. Let me just check my computations. Okay, I might not be able to pull it up immediately because it's buried deep. Do one thing, just post it in the discourse. I'll be able to answer this question because
I am getting decrease only, but the answer is decrease, then increase. It is given up to 0.9. So 0.9, whatever the value we are getting, maybe if it goes up to 0.95 or something, that may be increased, but up to 0.9, it's still decreased.
1 second, let me just check. This was question number 6, right?
Yes, sir.
So accuracy 0.47368, 0.47364, 423642. This is what is happening for me for threshold of 0.6, 0.7, 0.8, and 0.9. It is first decreasing. Sorry.
No,
it is decreasing.
It's same.
Same.
0.5, 0.6, it is same. It's then decreasing.
Decreasing.
Then
It's
decreasing.
increasing. 0.36 and 0.42, no?
But but for the 0.6, it is not decreasing. It is
Fine.
constant.
Okay, for these two, it's constant.
Yes, sir.
Come on, I've said from 0.6 to 0.7 to 0.8 to 0.9. You are telling 1 point it's constant, and you're challenging me saying that this is constant, so it's not decreasing. It is decreasing from 0.47 to 0.42.
Yes, sir. Yes, sir. That's why I'm saying that it's not decreasing for 0.6.
For this
But-
point, it is not, but it is decreasing, then increasing.
Yes, sir.
So 1 point, it may not be the thing, man. Out of 4 points, 1 point is constant as compared to your previous value, and then it's
Yes,
decreasing
sir.
and increasing. So it is decreasing and increasing. That is your answer. So the answer is right.
Sir, there is one question very common in the assignment 2.
Assignment 2.
Yes, graded assignment.
Graded assignment 2. Okay, graded assignment 2, I might not be able to answer, but I'll give it a
Yes,
shot. Yeah.
sir, the only one problem is that everything is the right, every code, every value is the right. Only one problem. Question number 3 and question number 4. If you see that beta naught and the beta 1 value. So, but it is, suppose I did is the completely question is based on the machine learning. So in that I use the regression, and for the regression I need one predicted value and the rest of thing is feature. But in the question has given only 2 columns, but it is not clear that which column is used to prediction and which is used to features.
Come on, I'm
So,
telling you, this question was also asked in the discourse, and I said I cannot turn it, and then the other person learned. I don't know whether you asked me. Please not take it as a personal thing, but the question says a company tracks the level of sales at a retail outlet for different retail prices. So obviously, sales is not in your control, price is in your control.
Okay, so this is only the things. It is not clearly mentioned. So I have to go through this statement only.
You have to go through the statement, of course. The statement says the company tracks its sales for different prices. So obviously, price is your control, sales is your output variable. Why?
Okay, sir. Then,
What more can be said, man?
okay.
No, we are this course. We are not going to say explanatory variable equal to price, response variable equal to sales. We are not going to do that.
Okay, sir, that's my bad then. I thought the reverse way. So just only one thing, I just reverse the column and the everything. The beta 1 and beta naught can change different. Otherwise, everything is the comes in. Even I change the value because loss, error, everything, chi-square value, every score comes in. Only that this beta naught and the beta 1 changed. Thanks.
But yeah, but intuitively, sales cannot be in your control. Only price can be in your control. So you should always take price as your X and this as your Y. Yeah.
Sorry, that makes sense.
Yes, Arya.
Good evening, sir. So I just wanted to, so I think you already responded on discourse about the first graded assignment question 5, right? So I just wanted to understand like regarding, I had already put forth another way to tackle the issue, which was to divide it by the sum of the expected frequencies and take a conditional on that, on the probabilities.
I had asked you for your numbers. So can you explain?
Yeah, I had put the numbers like 11.87 and 0.45.
No, I wanted for each of those things. Basically, your expected frequency without your technique. Then after your technique, how each of those changes, then bring it out.
Okay.
Because if my understanding is right, you are doing, instead of doing an equal split, you are doing a proportionate split based on your base theorem.
Yes,
if you're doing a proportionate split, then you are changing the underlying condition itself that the probability mass function, the PMF for your Poisson distribution itself is not getting hold. So you can't do that technique. That should be the answer. So I just wanted to verify your numbers and give it to you. So that is why in fact when you evenly split it, what will basically happen is the change will also be the same. That is why your chi-square value will not change.
Okay. So regarding the point that you were saying regarding the like the Poisson changing, so I agree with that. Obviously, the Poisson, like the PMF values will change, which is
the PMF formula itself is changing.
Sorry,
you get my point. What I'm trying to say is the value that you get from the formula itself is changed by your method.
So which formula are you referring to? I'm
What is PMF? E power minus alpha, alpha bar T.
okay. That you're talking.
Correct. That itself is changing for every single point. It's not a uniform change. You get the difference.
So the reason. Okay, I'll let you continue because I'm sorry, I keep interrupting. So
No,
if you once you finish, can you let me know? So then I'll.
Yeah, go ahead. But the thing is, when you change that value for everything proportionately, the interpretation of the probability itself changes, right? So it's no longer a Poisson distributed value. So that is why your technique will not work here.
Okay. So, sir, that I agree with. I mean, I understand that the values will change because obviously when we divide it by the sum, so the values will obviously change. But if I like look at from machine learning, like we already do something similar for like naive Bayes and other kind of algorithms.
That's a classifier.
Right.
Correct. The boundary can be anything. That is where it is. The boundary can be anything. Here the shape has to follow the distribution's original values.
Okay.
You get my point?
Okay.
So that is why it is different. When you are doing a classifier, for every classification, it can be a non-linear boundary. The shape is defined by you. Whereas here, the Poisson's shape is defined by your input parameters.
Okay.
That is the difference.
Okay. And the second thing is that like regarding the binning, I had also put some doubts on that same thread, which is that like there are some guidelines sometimes, like as far as stats 2 was concerned, like the foundation course that we had. So there in some videos, Professor Andrew says that like we need kind of try to ensure that for every bin there is at least 5 observations in the like in the observed table. But when we look at the second, like the first assignment over there, we had observed where there were like only 1 or 2 observations for some buckets at the end. So why don't we combine? So how is the binning like decided? Like
you can,
but if we combine them, then the value
your chi-square value will change.
Yeah, the chi-square was also changing. The p-value was also changing accordingly.
That is what the fundamental thing that all of you have to understand is the chi-square value will change, the p-value will change, but whether you accept or reject the null hypothesis will not change. The end result is always the same. Okay.
Yeah.
Here, why we are asked, like I said, this is all auto-graded assignments. So we cannot incorporate all possible scenarios. So what we have done is take whatever we have got, compute the chi-square values and give it to me, is what we are trying to say.
Okay.
So that is why we are telling we stop with that. Use whatever is given.
Okay. But as in like just theoretically and practically speaking, so can we bin it with 5 observations? Is that a valid?
You can.
Okay.
By the way, since you mentioned theoretically, there is no sacrosanct rule that every bin has to have minimum 5, right? There is, I mean, empirically, what Professor Andrew says is correct. Since you mentioned theoretically, there is no basis to say that every bin has to have certain minimum number, right? There is no theoretical rule as such.
Okay, sir. Understood. And last question is about like the chi-square test itself. So like as far as SciPy, like I think we already had a discussion earlier also on Discourse, which was that earlier versions of SciPy did not use to check for this condition that the expected and observed frequencies are same by the tolerance level, which they decide by themselves. It's 1e minus 8, I believe. Now they've introduced it, but as far as the test by hand is concerned, let's say from any, like if there's a quiz question or anything, so like do we ensure that, like I'm just talking from a theoretical perspective, is that a requirement of the test itself that there needs to be the expected and the observed frequencies to be the same, or is it something that we just want it programmatically? What is the like idea on that?
It is not right to have an expected observed frequency not equal, right? You have 101 samples. When you test, you should obviously have the same thing. And for some reason, what will happen is here it is very close. But for some reason, let's say in the same data set. Okay, I do not have the data set with me here right now to display, but let's say in the same data set, you had 12 buckets, 0 to 13 buckets, 0 to 12. let's say for some reason in between the value 10 was missing, okay, in the sample. So what would have your buckets would have been 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There would not have been 10. You would have had 11, 12. Okay. Then
Yes, sir.
if you do it by hand, there'll be a huge difference.
Yeah,
Then at
also
that
the
time you should
degree of,
go, at that time you should go and check, okay, why it is happening, and then you should see 10 is 0, so you put 10, observed frequency 0, compute this thing, and then you take whatever is the difference, right?
yeah,
It's the same thing when you are doing it now also. The only reason is when you are having 12 buckets, the rest of the frequency should be greater than or equal to 12 because you're comparing the observed versus an expected frequency, where the expected is always greater than. You could have 13, 14, 15 in your population. It just did not come in your sample. So you should always say the last bucket is greater than or equal to the value that you have in your sample. And for that, you should take the probability, and when you take the probability, it's 1 minus all the other probabilities. Now you put, it will always match to 100. It will always match. So then your observed and expected will always match.
so
And it is
one
a
thing
requirement.
yeah, okay. Yeah. So regarding that only, like one thing which I had earlier done, which was that instead of merging it in, like modifying 12 as 12 plus, what I had done was introduce like 13 plus as a separate bucket.
Correct.
So is that a valid thing, or that is also wrong in some sense?
Of course you can do. Like I said, the only thing that will change is your chi-squared value will change.
Yeah,
your p-value will change. Your degrees of freedom will change. But your end result, whether you accept or reject the null hypothesis, will not change.
Okay. Okay. So
You will
so
still lead to the same conclusion.
okay, and so like also for the example that you were talking about, where let's say 10 is missing from the middle part, even there, if I make it as a separate bucket and have observed frequency 0, or I merge it with 9 or merge it with 11,
you can say,
the result will be
above, you can say 9 and above, and then compute everything. You'll your end
result so the decision will be
the same.
Yeah, okay. So the decision will be the same, but the values will be different. So that is only where the changes will occur, right?
Correct. Yes.
Okay, sir. Yeah. Okay. Thank you, sir. Like these were the doubts.
No issues here.
Sir,
Yeah, go ahead.
I'm sorry. Sir, I have a general thing. Actually, sir, I have collected some load data from a power distribution company. That load data is available with me in every 15 minutes block in a period of more than 2 years. This data I have, and I also plan that I will take some weather parameter, means the humidity, rainfall, all these things from the during that period from the website. And also I want to plan, I want to take whether there is any festival or big incident, that as a input point. So all these things I have considered and want to perform a linear regression with this data to forecast the load in future. Is it means, am I thinking in right direction, doing this multiple linear regression with this parameter as an explanatory variable, and my target is the what will be the load in the say in next time block?
Rahul sir.
Okay. Just make sure that all the assumptions of ML are hold, right? If you have data, you can always fit a statistical model, right? Should that be enough to justify that this is the good multiple linear regression model? First of all, theoretically speaking, do you expect the relationship between weather and electricity load to be linear? I don't know, right? Now you have collected data which nicely may fit into a linear curve. Is the theoretical relationship linear? Can you justify a linear relationship theoretically? I don't know, right? I'm not from that background, so I don't know, right? As a data science person, right? I mean, always I go back to free economics. You can take 2 columns of data and do all kinds of analysis on it. And then you say, oh, column 1 had this heading and column 2 had this heading. And contextually, they don't seem to be any way associated. Can you still do statistical modeling using these 2 columns of data? Yes, you can. Purely empirically, you can run these algorithms, right? So first thing I will suggest that you do is establish theoretical relationships and make sure that they fit into a linear relationship, right? I don't know. I don't know whether it should hold or not. Similarly for other variables. Having decided that you are going to run an empirical model, make sure that all the assumptions of MLR hold, right? As always true, MLR, extrapolating from MLR, well, particularly in a electrical load kind of a setup, I will always be little wary because I don't know whether the electrical demand has plateaued or electrical demand still has a positive trend, or I don't know, right? So as the time increases, is the linear is the consumption of electricity or the demand for electricity growing? I don't know, right? Or has it come down, right? So all that will have to be looked at. So that's my answer. Arya has a question, but it's
Sir,
already
actually, with that data, I initially plotted that to see what kind of pattern it is following. I observed in a certain band, it is a some sort of cyclic.
Samit.
Yeah.
Let me not. This kind of exercises can be done as a hobby, right? Let's not. I mean, let us keep this discussion offline. I will answer your questions patiently. Post it to me in some format where I can answer. But since this is not related to the course, right? Anything that we have done in the course, let us keep this aside.
Okay, sir. If I want to communicate with you, sir, means I do not know your email.
There must be some way to get my email and drop me an email. I'll answer. Yes. You may have more questions, but we are out of time, right? And I do have another meeting to attend to. Let's so therefore end the session here. I'm sorry for all the confusion that we had. This should never have been a session for BA. This was meant to be a session for 4.0. But good. I'm still very happy that we could meet. So we will continue to meet in the BA course, right? Keep your messages coming, and me and our team will make sure that they are all answered. Is that all, Malalan?
Yes, sir.
Sure. Thank you, Rohit, for explaining a priori so beautifully again. Thank you.
Thank you, sir.
Thanks, everyone. Thank you, sir.
Yeah. Bye, everyone.